All right, folks, so today we're going to take a look at this device. It is an RF Explorer 4G Combo Plus. RF Explorer makes a couple of different devices, and we'll take a quick look at some of the other ones. But I was lent this by my buddy Meshtastic Dave, and he works with Seed Studios, so this is from Seed Studios. But they didn't give it to me directly. I think they gave it to him to give to me to do a video on, but I got to give it back. That said, I don't know if this is a sponsored video or not, but if you're the type of person who gets triggered easily by sponsored content on YouTube, I suggest you go watch some cat videos. Now, the RF Explorer Plus Combo 4G Combo Plus. Anyhow, this is a pretty rugged device. It feels pretty heavy in the hand, and it has a solid metal case. And this is something that field engineers would use to detect, monitor, measure ambient RF that's being transmitted by various devices. You can connect something in here to feed it a signal, and we'll do that with a signal generator a little bit later just to do some tests. But I think this is mostly used in field operations. It has two different frequency ranges, and you can see that here by the two different antennas. This antenna that is over here is telescopic, so you can extend it to make it more appropriate for the frequencies that you're trying to detect. It has one of these old school USB ports on the side, and you use this to connect the RF Explorer to your computer, so you can run some computer software on it, do things like firmware updates, you can monitor the screen, and then it also has some other control software. But you also charge through this port as well. Now you can run it off of this port, leaving the button in the off position, or if you turn it into the on position, it will charge the battery that you're connected to. It also came with this case. Now when I got it, it didn't come in a box. Dave just handed me this case, and I opened it up and saw what was inside and got pretty excited. It was this device. And let me open this up real quick. So I don't know if they ship with more than this or not, but it's a nice protective case. Open it up. Here is the USB cable that you use to charge it. And here's a little teeny antenna, I guess, for higher frequencies. It has a SMA connector, and in the event that you're only using one antenna, I guess you put this on the other one. And then it came with the most handy thing of all, one of these twist ties. All right, now that we got that covered, let's take a look at the device interface. All right, I zoomed in a little bit so we can get a better look at this. But here immediately when you turn this thing on, that's not how it normally comes up. That must have been the screen that I left it off on. We're going to go through a slide that I put together that shows all these little icons and what most of them mean. But it has this 9-button interface here, and that's how you get around and how you do different things. So there's Spectrum Analyzer mode, which is what we're in now. It has a Wi-Fi analyzer, and we'll look at that later. It has this thing called RF connections. And this is where you can see which one of these is active and which one is not active. It also shows you the frequency range. So this antenna over here is 50 kilohertz to 960 megahertz. Right now what we have active is 240 to 4 gigahertz, and that's on this antenna right here. I can scroll through different settings by doing that. Let's take a look at the battery. This tells me that my battery level is around 63%. And we can go down to about. Now taking a look at about, this is where I found out what model this was, because when I got it I didn't know. There's no marking on it. So 4G Combo Plus, and the version of the firmware is from 3/20/01, and it says February 21. It's a 3.20 February 21. So the firmware is pretty old on this, and we're going to attempt to update it. Let's go back. And then here are a couple of different things. Like you can see this serial number for the main board and the expansion. And I don't have any of the extra firmware licenses that are available for this thing. And you can set your frequency when you're doing scans. So this has a center frequency, a frequency span, start frequency. All this is something that can be manipulated. And if you come down here to module and then you hit this button, then it switched let's hit it again. Now it's switched back. But every time I hit this, it'll switch the active antenna. So right now we're on the smaller antenna, or the lower frequency antenna, I should say. And let me hit that. We're going to go back, and then I'm going to hit this button. And there's some other things that you can take a look at. One of them is the calculator. Right now we're set on max hold, and we'll take a look at those. I want to talk a little bit before we do that around this input level. So I have some slides that explain this, but for the input, direct means your signal is coming directly in via the antenna or direct connection, and then going right into the the brains of this this device. If I hit this button, I can set a 30 dB attenuator. And there are certain cases where you're going to use that. And then I can also set a low noise amplifier or 25 dB amplification of any signal that's coming in. And 60 dB attenuator, and there's back to direct. And we're going to leave it on direct for right now. We might change it to one of the other ones depending upon what tests we do. Let me go back. And here's the regular screen. So what you can see is that we have a max hold. So each one of these lines represents a certain data point where signal strength is collected, and it goes up and down. But the line stays where it started to see its strongest signal. So if we go back into the menu and then we go back up here and change max hold, we can change, oh, I didn't mean to do that. I can pick this and now it is set to normal. So let's go back and see what it looks like. So you can see that that max hold is gone, and then now we're getting a peak marker that is moving around. It's adjustable to whatever the strongest peak is. Let's go back into here, and we can change this to max. And let's go back. And then what this does is that it just stops and it shows you the max signal that came in. And what it doesn't show you is the live data that's underneath of it. Now this might be helpful if you were doing some signal hunting on a particular frequency. Like maybe you were using Wi-Fi and you wanted to see where the strongest Wi-Fi signal was coming from. Let's go back over here and let's go, oh, I keep doing that. See, keep doing that. So this is averaging. So this is when you want to collect an average number of counts, and then it will show you what that average is. It doesn't show you real time. That's pretty handy too. Let's go back to the menu. Let's hit this button again, and this overwrites. So it'll collect a high point and then overwrite it when it sees another one. And let's go ahead and take a look at that. I don't like this one because it just makes that spectrum line a big, fat, and porky, and I don't like it. I like the max hold, so I think that that's where we're going to leave that thing. This took me forever to find, but this is the backlight. I have it set pretty low right now, so you can see it on my camera. And oh, this is presets. So you can set presets in here, and there's actually some software I think that comes with this that you can use to generate your own presets. And you do that if you have particular measurements that you make on a frequent basis. So you go into your environment, you fire this up, you pick your preset, and it's already pre-configured for you. Now, it has the ability to record on the device. This does not have a license to do that. And what I wanted to show real quick is this Wi-Fi analyzer. Now, this only shows up when the second antenna is active. But let's go ahead and pick it. And then you can see this is looking at 2.4 gigahertz Wi-Fi's channel 1 through 13. And you can see what channels are the most active. And this would be pretty handy if you're doing any kind of Wi-Fi analysis. Now, what you're saying is that, Ape, what is the use of something like this to an amateur radio or ham radio operator? Let's go back. This says Wi-Fi analyzer. Let's go down to RF connections. I'm going to go ahead and I'm going to hit this. And I think this button is the one that switches it. Oh, that's not where I want to do that. That's why. Let me go back here and module, hit that. And now we've made this the left antenna here active. So let's go back and take a look at what we have here. Now, if you'll notice that Wi-Fi is missing. In the newer versions of firmware, there's something that says ham module. So there's a ham module that you can use that will allow this to be used as a relative field meter. I don't believe any license is required for that, so we're definitely going to update the firmware and see if we can work that. In addition to that, you could use this to do any RF exploration in your house, EMI detection, something like that. Like I said, you can feed a signal in here, and then we're going to use an HT external to this device, and we're going to see what the signal looks like. So there are ham applications for this. And again, this is probably something that is a little bit more rugged and something that you would use more in a field day setting. Okay, I'm not 100% sure what's going to happen here because I've never updated the firmware on one of these devices. But I have the device plugged in the computer. You can't see it because it's not on the screen right now. But there was this piece of software that came with the software package that I download from the RF Explorer's website on the software section. And it's called the RF Explorer Uploader version 4. And so once I started that, it had this next button. So I'm going to go ahead and I'm going to click next, and we're going to see what happens now. We have an hourglass. Okay, it did something. This is the selected COM port, port 9. I checked that when I plugged it into the computer. That's the one it's on. And it selected, it auto-detected this baud rate. I'm just going to leave it where it is because, again, I don't know what I'm doing and I didn't read anything in the manual about it. I click next again. Okay, and now it's reading some stuff and it's saying that the device firmware has been detected. It says there's a new firmware available. Click next for more details. Let's go ahead and do that. And it says 3.45, and then here's some release notes, but we're not going to read those because we don't really care. So let's go ahead and hit next. Please confirm. I got a pop-up box over here. It says, please confirm you want to upgrade your device. Okay. Press the up button on your RF Explorer to start the upgrade process. Okay, I pressed it. And now it's doing stuff. And this is moving pretty fast. I didn't expect it to go like this. And it says it's done, except for there's nothing I can do here. Oh, there we go. Now it says process complete, device is ready to use. I'm going to go ahead and I'm going to hit next. And there's a button for some release notes. I don't want those, so I'm going to go ahead and I'm going to hit close. And we're done. Okay, so here we are. We're back at the device, and let's go into this menu. And here you can see it says ham field meter. That wasn't there before. Let's go down and hit that, and we're going to experience this together for the first time. And then I'm going to hit that button. And so it shows ham field meter, and it says R30, and it's showing, oh, this feature requires a license. Please visit this page for more details. Well, I'm not going to buy a license for it because it's not mine. But rest assured, this is something that you could use if you had a license. So that's a little bit of a bummer that we can't do that. But what a field strength meter does is allows you to get relative measurements of RF coming off of a device like an antenna. And so what you would use this for is, say you had an antenna set up and you wanted to see if it had a signal strength in a stronger direction. Maybe it's not a directional antenna, but maybe you have a dipole. Maybe you want to argue with me that that's a directional antenna. But you could walk around that antenna while it's transmitting and you could see where the powerful lobes are and where the null points are. You could also do something like check front to back ratio for relative field strength on something like a Yagi antenna. Also, let's go down into the about. Hit that. And then you can see our software version has been updated to 3.45, and it says February 13th, 25. So the firmware is 4 years newer. Okay, here we are at Seed Studios, their website. And if I go over to products, and actually let me hit this, I think it's under instruments and tools. And then they have these RF Explorers. They have a bunch of them. And this one over here looks pretty cool. The RF Explorer Pro Touchscreen Spectrum Analyzer. I don't have this one, so we're not going to spend too much time looking at it. But it's a little bit of a portable / desktop spectrum analyzer. And look at that, $1,200. Now this probably changes. Oh no, it's the only option that they have. It ships from California. Maybe I should order that thing. Let's go back over here. And here's a whole bunch of different things. Raspberry IoT touchscreen for Raspberry Pi. That's not an RF Explorer. But here's the 6G 449. Here's the 6G wireless B. I don't know what that B stands for. $399. Here is the ISM combo. Here are some attenuators. So they're calling it a power limiter. And then here is a 66 gigahertz 2 watts SMA attenuator 10 dB. And you would use those in the event that you were measuring stronger signals. Here's the RF Explorer 4G Combo Plus Slim. This is the one that I have. And it looks like everything here I showed that it comes with. Here's the device with 2 antennas on it. And here's the device in somebody's hand. But you can pay with PayPal. So what we're doing here is we're taking a look at some computer software that comes with the device. You have to download it from the website, and I did that. And when you download it, it installs a bunch of packages like the firmware updater and this particular piece of software. This is the newer software. It also comes with the legacy software. But you can see it down here, it's starting to collect a waterfall. Now, I went in and I set my frequency by hitting this button here, frequency, and then I can hit center, and I can adjust that. Or I can adjust my span right here by doing that. And I can go back and I can do things like set markers if I want to. Let's enable a marker here, and here's the active marker trace, real-time average, max peak, max hold, minimum. Marker text is on, and we'll just leave it at that. Okay, we're back, and let's see what else that we can do. I guess I could go to full screen, but I don't want to lose my control panel that I have here. And here you can see some marker information. Frequency, we already took a look at that. Config, let's see what that says. And we can fill a trace. Our real time is fill trace. Let's go ahead and turn that on. There's a thick trace, a smooth trace, a grid. Our amplitude is set for dBm. We could set it for watts, but we're not going to do that. And then we have our waterfall on. Here it says application display. We have dark mode enabled, which is nice. Alphanumeric keypad, numeric keypad. I'm not going to fool with any of that. Oh, you can set a limit line too. This would be handy if you're doing any spectral purity tests. And let's see what radio standard does. Here's some options here. Let's go ahead and cancel. Hit configure. Yeah, we're going to close that out. All right, here we go. You can see some stuff here. Now, I've got this little HT turned on. And we're going to key up on 14652 on low power. This is not directly connected, but it should detect a signal. Should be coming through any second. There you go, and we see our marker. And this is at 1459.297 megahertz. And what it's showing us is it's at negative 30.50 dBm. Now, suppose I could come down here and I could hit hold, and we could talk a little bit about this. Now, it took a while for the fill line to come all the way up to where the peak was, because the peak was in real time, and the fill is the average. And so the more samples it takes, the closer to reality that average gets. But this is pretty handy. You can control it via this particular piece of software. Let me hit exit. Okay, I'm a little bit of a dumbass, so when I hit the exit button, instead of exiting the screen, what it did is it closed the application. So now we're back, and you can see when I rebooted it, it's now from 50 to 650 megahertz, so it's 50 kilohertz to 650, and my sweep speed is super duper low on this thing. What I want to do is I'm going to hit this mode button, and let's see if we can take a look at the waterfall. And this is pretty cool because it gives you a time-lapse spectrum waterfall. And you can use this to take a look at different signals and where they might be for things that are intermittent. So you can see like we have a spike back here that hit. But this is really handy if you wanted to take a look at, if you were taking a look at different audio channels. For example, if you were doing some kind of Wi-Fi or microphone broadcast wirelessly and you want to make sure you didn't have channel collision. What I saw was these things are really popular in like auditoriums and things like that. Folks use them a lot there to do an analysis of the RF in the environment. Now there's another piece of software that we're going to take a look at, and it's the legacy software. So let's go ahead and load that one. Okay, so here is the legacy RF Explorer for Windows. It's running. Up here at the top, we have some controls. We have a mode, trace mode, spectrum analyzer. What I want to do is I want to go ahead and I want to set my center frequency right here. I don't know why it's set so high. Let's go 144, which is where we were before. And let's just do a span of 4. That should be 4 megahertz. And I'm going to hit the send button to send that to the spectrum analyzer. And there you go. And it looks like the bottom part of this is cut off. I have my radio here that we had before. So let me turn this baby on.
Welcome, frequency mode.
There we are, we're in frequency mode, and we're at 146.5. Let's go ahead and key up. And we're not going to see it because I'm a dummy. Let's go ahead and set our span to 8. Send. There we go. The frequency I was transmitting on was out of the spectrum. So let's go ahead and key up now. And there you can see it. Now, one of the things that was pretty handy about this, which I thought was kind of cool, is that we're going to increase the span. Okay, right now I've keyed up a radio and we've adjusted the span so I can get my primary frequency, which is all the way down here on the left-hand side. But you can see that when I transmit this radio, look at all these harmonics and spikes that I'm getting. But I've got one that's almost equally as strong at 439 megahertz, and that's a little bit crazy. This isn't a very good radio, by the way, and that's why I used it for this demonstration. And we take a look at the software. There's some other stuff. There's this power channel. I have no idea how to read this and what it means. I can take a look at my remote screen. And let's see, enable remote screen capture, and here's what it's showing you. And then that has a signal generator mode, but I'm not licensed, or this device actually doesn't have the signal generator built in, so we can't use that. Anyhow, there's two pieces of software, and I wanted to show them. All right, so let's talk a little bit about the different models that you can get. And this is just this particular style. There's other styles or models of the RF Explorer. But you have the 6G combo. Here you can see the different frequency spans. 6G WB, I don't know if that's Warner Brothers or not. 4G combo plus is the one that we're using here. It's expandable up to 6.1 gigahertz with license, and I think the correct expansion board. This one has the 4G card in it, and then has the ISM combo plus, and then the this is the wire, I guess Wi-Fi sub gigahertz plus. It goes 550 kilohertz to 960 megahertz. You can also get the slim holder. This is just a quick coverage chart that shows the different frequencies that you can get for these particular devices. I got this stuff from the instruction manual and just pulled out a little bit of data that I thought was relevant. Here you can see the explanation for the spectrum analyzer screen. So we'll start down here at the bottom. You can see this start and center frequency and your stop frequency. The bottom visual amplitude, so that is the number on the bottom of the scale that runs vertically. DSP mode, this is a type of filtering that you can use. Calculator mode, we covered that. That is the composition of the line and the line characteristics. Amplitude unit is the value of the vertical line here, and we have it in dBm. Sweeps per second. It says 5 sweeps per second. USB battery status, this one is on USB. Top visual amplitude in dBm. This is at -1. Here's a marker that is highlighted, and this shows you your frequency at the marker position and the amplitude at the marker position. Pretty standard spectrum analyzer stuff. And we took a look at the Wi-Fi analyzer screen. This is showing you that max hold is enabled, so you can see where the signals, what channels are the strongest. Channel selection, 2.4 gigahertz. Maximum detected power level, current power level. Now, this one, I can't look at 5 gigahertz because the device doesn't go that high. Now, we talked a little bit about the input range, and we have it set for direct. And now this is the reason you would want to change that. So the signal that you're measuring, measurable input range. So if you're lower than 30 dBm or 1 microwatt, you just leave it off, right? You leave it on direct. If you're measuring things that are 30 dB to 0, it says 30 dB external or the internal attenuator. Now you can connect an external attenuator to this if you need to. 30 dB to 10 dB, 1 microwatt to 10 milliwatts, 40 dB external, and then here is 0 to 33 dBm, 1 milliwatt to 2 watts, 60 dB internal. Now, if you're feeding a signal directly into this and you don't know what you're doing, it's very important to use the external attenuators because spectrum analyzers have very sensitive front ends. And believe me, they're easy to let the magic smoke out. Here is a little bit of an explanation on the changes that we made when we were changing the selectable input stage. And here's your 50 ohm RF input that is on the radio, so the signal's going from left to right. If you leave it on direct, it just goes straight through. And if you pick the attenuator, and we had 30 and 60 dB attenuation settings, it would go through your internal attenuator. Here it has a resistance symbol to show you that. And down here is the LMA amplifier for 25 dB. Now you would use this if it's a very, very low noise and you wanted to get a good signal measurement. I talked a little bit about this piece of software that it comes with, and this is the device preset utility, and this is for the different presets that you want to set. So you have start and stop frequencies, amplitude configuration, calculator mode, and then you could have marker mode in here as well. And then you would just upload this to your device. Now, the thing that we weren't able to use is this ham field meter, but here is the ham field meter screen. And what this is showing you is 109.18 microvolts per M. I don't know if that stands for meter or whatever. I don't know how to read that, but I do know a lower number is a lower signal and a higher number is a stronger signal. This is showing you the frequency span for that. Now you can use an offset dB, and that is in the event that you need to tune this because maybe its calibration is different than what you expect. And then this just shows you which ham band you're going to be on, which frequency band here you want to be using. And this says suggested antenna gain offset dB. This is all TBD, and I'm not 100% sure what that means because I don't think it was clear in the instruction manual. This is the uploader tool, and we saw a live demo of that. So you can see you just download it, and then it says run the updater tool and follow the on-screen instructions. We did that, and it worked fine. Okay, what we're doing here, and if you're going to do stuff like this, be careful if you don't know what you're doing. I'm not really careful, so I don't know why I'm telling you to do that, but you really should be careful. Anyhow, I'm just going in direct. I'm not running through an attenuator because I don't need one because I have a pretty controlled signal here. We're using our tiny SA Ultra, and what this is doing is I'm running a frequency at 146,500, and I'm running it at negative 40 dBm, which is in the safe zone for this device, and we don't have a sweep on. But I'm just running an output of a sine wave, and then you can see that here on the device. So it's saying 141.891, so it's a little bit off, but that's probably because we're fitting 900 megahertz of spectrum on this little teeny screen. And it's showing negative 38.0 dBm. And I think that's okay. So let's mess around with this a little bit. And we're going to go ahead and we're going to hit this menu. And I think I want to keep going like this. And let's do our center frequency at 1. Well, we can just do... Okay, there we go. That was a little bit more wrangling than I originally wanted. But let me go ahead and hit back. And then there you can see that signal. Now it says 146,531, so it's a little bit closer. And this may be off. That might be the right frequency. But we also have a more accurate number at negative 39. And it allows us to measure that signal. What I'm going to do is I'm going to go ahead and I'm going to turn this off because I don't want to risk doing anything stupid. But what I'm going to do is I'm going to come over here and I have sweep off, and let's go ahead and hit sweep on, and it's going to give me a little bit of stuff here. So for the span of this, I'm going to go 1 megahertz. That's a little bit of a larger one. Level change none because I don't want to do that. Sweep time 2 seconds back. That sounds good to me. Let's go ahead and turn this baby back on, and now we can see that sweep is taking place there. Okay, let's change this to, we'll do a 4 megahertz sweep. And sweep points, we'll do 450. And we're not changing anything else. And we have this set. Let's go to mode. Oops. Output, we have a sine wave modulation none. Let's go ahead and set this for FM. And this is going to get us there a little bit quicker, and it's going to show us. This should keep going up until we get close to that negative 40 measurement. Negative 40 dBm, I should say, measurement. And we're starting to get there. Anyhow, it's a fun little device to mess with. It does have applications in amateur radio, so for all of us hams that look at this stuff, maybe it's something that you want to check out or play around with. I do wish I had the license where I could take a look at the ham module where we could use this as a relative field meter, but alas, I don't have it, so I can't test that. But it's a cool little device. Anyhow, what I want to say is thanks to Seed Studios for sending this to Meshtastic Dave to give to me, and it was pretty cool. Thanks for watching, everybody. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below, and I'll do my best to respond.